Okay, so now we and 15, right? 12, 13, 14, 15. Question number 12. Let me draw the figure for you. Question number 12 says, from the top of a 7-meter building. Okay, so the figure is like something like this. From the top of a 7-meter high building, the angle of elevation of the top of a cable top is 60 degrees. So again, it's a question where you have two objects of different heights. You have two objects of different heights. One is a building. The height of that building is given to you as 7 meters. So this is 7-meter building, and this is a tower whose height is unknown. We have to find out the height of this tower. But what is given is that when we look from the top of the 7-meter high building, the angle of elevation of the top of the tower is 60. So I'm looking upwards. This angle that is being formed here is 60 degrees, right? This angle that is being formed here is 60 degrees. And the angle of depression of the foot is 45. So you're looking downwards. Okay, this angle is now 45. So the height of the building is 7. And the height of this star is unknown, but this is 7. So this part is going to be 7. Let's put this. This can be assumed as small h. This whole height is capital H. Let the base be x. So if this is x, this will also be x. So this is going to be the figure for our question number 12. So the angle of depression. So when you're looking downwards, that is called the angle of depression. But as I told you in the first class, that always remember that the angle of elevation and depression are equal because they're alternate angles. So for calculation purpose, this angle will be 45. Okay, this angle that we are having here is 45 degrees. So this is 45, this is 45. So first I'm going to take the triangle ABC. I'm going to use tan 45. Tan 45 will be 7 upon x in this triangle. Tan is perpendicular by base, right? So tan 45 is 1. We substitute that value. Cross multiply, we get the value of x as 7. So x we have got as 7 meters. So this distance between the building and the tower is 7 meters. Now, next we go to triangle ADE. In triangle ADE, what can we say? In triangle ADE, we can say that tan of 60 is equal to h upon x. I hope you agree with this because this is the triangle that we are taking. Tan is perpendicular by base, so tan 60 is h by x. Tan 60 value we know is root 3. And this value of x that we have got, we can substitute it here. So we get root 3 is equal to h upon 7. Therefore, what is h? H is equal to 7 root 3. Now, what is the height of the tower? The height of the tower is capital H. And if you observe from the figure, the value of capital H is small h plus 7. So capital H will be 7 root 3 plus 7. 7 we can take common. So height of the tower therefore will be 7 root 3 plus 1. Right? So that's going to be the solution for question number 12, that the height of the tower is 7 bracket root 3 plus 1. Moving on to the next question, question number 13. Question number 13. As observed from the top of a 75-meter high lighthouse. So this is a lighthouse which is given 75-meter high. The angle of depression of two ships are 30 and 45. One ship is exactly behind the other. Now this is very crucial, that one ship is exactly behind the other, because sometimes in the exam they can say that it is on either side of the tower. Okay, so please read the question very carefully, whether they are referring to either side or whether they are referring to the same side. So in this case, the ships are one behind the other. So angles of depression are given as 30 and 45. So please remember that the ship which is further away will have a lower angle. So when you are looking at this ship, that angle is 30. So this will be 30 alternate angles. And when you're looking at the ship which is closer, that is going to be 45. So this is 45. This will also be 45. We can name our triangles A, B, C, D. Okay, so this is our light, that are 75-meter high lighthouse. From here, you are looking at the ship. That angle is 30. Always remember the angle of depression or elevation is with respect to horizontal lines. Okay, that's why I am putting a dotted line here to show that there is an imaginary horizontal line here. So this angle is 30 and this total angle is 45 and alternate angles we have got here. So if I'm going to take the first triangle, that is triangle DCB, then tan 45 is equal to 75 upon BC. Value of tan 45 is 1. Therefore, cross multiply, we get BC as 75 meters. So this length we have got as 75. Now what are we going to do? We are going to take the full triangle ACD. This is of course a right angle. Triangle ACD will use tan 30 is equal to 75 upon AC. Now tan 30 value we put 1 by root 3 and cross multiply, we get the value of AC as 75 root 3. So we've got the value of BC and we've got the value of AC. Now what is the question? The question is find the distance between the ships. Question is find the distance between the ships. That means we have to find this distance. This is the unknown distance that we want to find out. So what is the distance between the ships? Distance between the ships is equal to AB. And what is AB? AB is the same as AC minus BC. Therefore, we can say distance between the ships AB is AC we have found out as 75 root 3 minus BC we have already found here as 75. Therefore, the distance between the ship, which is D, is 75 common root 3 minus 1 meter. So this will be our final result, that the distance between the ships is 75 root 3 minus 1. So this is clear. Moving on to question number 14. Question number 14. Question number 14 says, a 1.2 meter tall girl spots a balloon. Now, a 1.2 meter girl spots a balloon moving with the wind in the horizontal direction at the height of 88.2. The angle of elevation of the balloon is 60. Okay, so you are looking at the balloon initially. The girl's eyes is here on top. So this is the balloon. This angle at which this girl is watching this balloon, angle of elevation is given 60. And after some time, the angle of elevation reduces to 30. That means the balloon is moving away from her. That is why the angle has reduced, because if it was coming towards her, the angle would have increased. Now the angle is getting reduced, means the balloon is moving away from her. So the balloon has moved from here to here. And now when she is watching this balloon, this angle has changed to 30 degrees. So when you're close, the angle is going to be greater. When it is farther, it is going to be less. Right? So let us name these. Okay, let the position here be M and let this position be N. So the balloon has moved from M to N, and the question is find out what is the distance traveled by the balloon. We have to find out what is the distance traveled by the balloon, right? So distance traveled by the balloon is mn. So 1.2, and this total height of the balloon is 88.2 from the ground, and this is 1.2. So 88.2 minus 1.2, the distance from N to E will be 88.2 minus 1.2, that will be 87. So for calculation purpose, I will be using 87 because the triangle's height is 87, not 88.2. So first what we do is we will take the triangle AMF. Okay, I'm taking triangle AMF. I can use tan 60. So tan 60 is perpendicular. We have found out 87 upon the base length as AF. Substitute the value of tan 60, root 3. Cross multiply root 3. AF is 87. Therefore, we can say AF is equal to 87 upon root 3. I'm going to rationalize this, multiply and divide by root 3. So what happens? I'll get 87 root 3 by 3. So what do I get? I get the value of AF as 29 root 3. I get the value of AF as 29 root 3. So this is this value that I'm getting from here to here, 29 root 3. Now I'm going to take the next triangle, that is triangle ANE. I'm going to take the triangle ANE. I'm going to use tan 30 is equal to perpendicular. So the perpendicular is 87 upon the base length, which is AE. Right? Tan 30 value is 1 by root 3. I'm going to substitute that. Cross multiply, I'm going to get AE as 87 root 3 meters. So what happens? I'll get the value of AE as 87. Now, if I'm going to subtract AE and AF, I'm going to get the value of FE, and FE and MN are basically equal. So in the next step, what I'm going to do, I will find out the value of FE. And what is FE? FE will be AE. Okay, this is very clear from the diagram. FE will be AE minus AF, and both these values we have found out. So FE will be 87 root 3 minus 29 root 3. Right? So we have 87 root 3 minus 29 root 3. So when you subtract this, you're going to get 58 root 3. So therefore, final answer we can say distance traveled by the balloon. What is that? MN is equal to 58 root 3 meters. So what is the distance traveled by the balloon? The distance traveled by the balloon is 87 root 3 minus 29 root 3, and that will give you this answer 58 root 3. Okay, so final answer is 58 root 3. Okay, then kindly mark this question 15 and 16, very important sums. Question number 15 and 16 are very important. Question number 15, please mark important. Okay, so let's do question 15. A straight highway leads to the foot of a tower. This is the tower. A man standing on the top of the tower observes a car at an angle of depression of 30. So a man is standing on top of the tower and observing a car coming towards him at angle of depression 30. So that's why I'm taking this 30, but here alternate angles are equal, so this angle will be 30. This is approaching with a car. This is a car. Okay, the car is moving towards the tower with a certain uniform speed, and after 6 seconds, now this is very crucial here because time is mentioned. This is not the distance, this is the time. After 6 seconds, what happens? The angle of depression of the car was found to be 60. That means the car is moving towards the tower. That is why the angle has increased. So this angle of depression, that means when you're looking from top to bottom, has become 60. That means this angle is 60. So now this becomes our figure, and the question is now, how much time will it take for the car to reach from the tower to this point? From this point, how much time? So this is 6 seconds. how much time is it going to take for the car to reach from C to B? This is a different question as compared to the others, right? Because there is a time here. So first of all, we don't know what is the speed. So let us assume the speed is X. We are not aware of what is the speed. So therefore, we are assuming the speed as X. So once we assume the speed as X, we know that distance is speed into time. You have done this innumerable number of times. So I can say the distance traveled by the car from B to C. Okay, we are finding out this distance from B to C is speed into time. So X is the speed, time is 6. So this distance is 6x. This distance is 6x from B to C. And now if you look at the next part, that is distance from C to B is over. Now this is distance from D to C. Okay, DC. This distance is 6x. Speed is x, time is 6. So distance from D to C is speed into time, x into 6, 6x. So this is DC. Now we are finding out the distance from C to B, this distance. So speed is the same, x, but the time we are not aware, that is assumed as t. So this distance is xt. This distance is xt. Now we go with the triangles. The first triangle is ABC. So we get tan 60 is equal to, height of the tower is unknown. Let us assume is at h. Let the height of the tower be h. So tan 60 is h upon t, perpendicular upon base. Tan 60 value we are putting √3. Cross multiply, we get the first equation that h is equal to √3t. The value of h we are getting √3t. Now we will go to triangle ABD. We are going to take triangle ABD. That is a big triangle here. So here tan 30 is equal to h upon, h is the height of the tower. The base, now what is the base? The base is 6x plus xt. We are adding this total, then we'll get the total base because we are taking the full triangle ABD, isn't it? So the total base length will be 6x plus xt. Value of tan 30 is 1 by √3 that I am going to put here, and this value we have already found out here. We'll put that. So √3 here, tan 60 is perpendicular by base. So base length was h upon, here I have to put xt. Okay. So this is going to be h is equal to √3 dx or √3 xt. So tan 60, what is the value? Perpendicular by base. Okay, it's not t, it's xt because we'll have to equate with the distance. So h value is √3 xt. I'm going to put that value upon 6x plus xt. Cross multiply, we get 3xt is equal to 6x plus xt. This xt comes this side, so we get 3xt minus xt. So we get 2xt equal to 6x. X will get cancelled and we get 2t is 6. Therefore, what is the time? 6 upon 2, 3. So in how many seconds will this car reach the tower? This will take another 3 seconds. So in answer will be in 3 seconds, the car will reach from point C to B. Okay, so you can mark this question important. This is of a slightly different nature if you compare with the other 14 questions. And finally, we move to the last question. That's also a very unique question, question number 16. The angles of elevation of the top of a tower, okay, from 2 points 4 meter and 9 meter away from the tower. Okay, this distance is 4 meter and this distance is 9 meter. And the angles of elevation, they are not given the angles, that is why it's unique, are given complementary. Now you remember this word complementary. What was the meaning of this word complementary? It means angles which add up to 90 degrees. Supplementary was angles adding up to 180. Complementary is angles adding up to 90. So we will assume let this be theta. Therefore, this angle will be 90 minus theta. If this is theta, this will be 90 minus theta. And here, what is the question? Prove that the height of the tower is 6. Already it is given that we need to prove that the height of this tower is 6 meters. Okay. So let's see whether we can prove this height as 6. So we are going to take triangle BCD first. In triangle BCD, we can say that tan theta is equal to h upon 9. Equation number 1. In triangle ACD, we can say tan of 90 minus theta is equal to, or tan theta here will be h upon 4. Tan theta will be h upon 4 because here we are taking the smaller triangle. Here we are taking the bigger triangle. So tan 90 minus theta will be h upon 9. Okay. So you can make the correction here. This is going to be h upon 4, right? Not 9. So h upon 4. So this will be h upon 4. Tan 90 minus theta is equal to h upon, this is h upon 4. So we are going to write this as h upon 4, right? So h upon 4 and tan 90 minus theta is equal to h upon 9. So we have two equations. Now you have to remember the previous chapter where we did tan 90 minus theta. You remember that tan 90 minus theta. In the tan 90 minus theta, what you did was, these were complementary angles. In the complementary angles, there was a formula that tan 90 minus theta is cot theta. Tan 90 minus theta was cot theta. So we are going to use cot theta here. So what are we going to use? We are going to use cot theta. So cot theta is equal to h by 9. Cot theta equal to h upon 9. So what have we got here? We've got tan theta as h by 4 and cot theta is equal to h by 9. We are going to equate this first. If cot theta is h by 9, what is, therefore I can say that tan theta is equal to 9 upon h. Tan theta is 9 upon h. Isn't it? Because cot theta is h by 9, cot and tan are reciprocals. So if cot theta is h by 9, tan theta will be the reciprocal of that, that will be 9 by h. So now if equation 1 and the equation that we have got right now, that is tan theta is 9 by h, if I am going to equate that, what will happen? I'll get h upon 4 is equal to h upon 9. I'm going to get h upon 4 is equal to h upon 9 or 9 by h. H by 4 is equal to 9 upon h because the tan thetas are getting involved. So here the first part I had got tan theta as h by 4. Now I have got tan theta as 9 by h. So I'm equating this. So when you cross multiply this, what happens? H square is 36. H square is 36. So h will be root of 36. And what will be root of 36? That will be 6. So that's how we can say that the height of this star is going to be 6 meters, right? So hope this is clear. So tan theta was h by 4. Tan 90 minus theta is h by 9. If tan 90 minus is h by 9, then cot theta will be h by 9 because tan 90 minus theta, the formula is cot theta. If cot theta is h by 9, then tan theta is the reciprocal of that, that will be 9 by h. So here equation 1 we have tan theta is h by 4. Now you've got tan theta is 9 by h. So we can equate this, we get h by 4 is 9 by h. Cross multiply, we get h square is 36. And if h square is 36, then h will be root of 36. And therefore we can say that finally that height of the tower is root 36, that is 6 meters. Of course, you may say that there is a negative case also, but height cannot be negative. So therefore we can say final answer, right? Thank you.